National 5, Unit 2, Nature's Chemistry, Fuels. A fuel is a chemical which burns, giving off energy. Combustion is a reaction of a substance with oxygen, giving off energy. The test for oxygen is that it will relight a glowing splint. The main components of air are oxygen and nitrogen in a proportion of 1 to 4. An exothermic reaction is one in which energy has been released, given out, so it feels hot. Finite energy resources will run out. This means there will be a fuel crisis in relation to the amount of coal, oil and natural gas in the earth. Fossil fuels, coal, crude oil and natural gas, were formed over 300 million years. Coal was formed from trees which fell in swamps, oil and gas from microscopical sea creatures, and plants which fell to the bottom of the sea. Layers of sediment formed on top of these, and under pressure the decayed material turned into fossil fuels. Sulfur is an impurity in fossil fuels, so when they are burned, sulfur dioxide is given off. This dissolves in rainwater to make acid rain. Carbon dioxide is also acidic and slightly soluble in water. Nitrogen dioxide is formed by an electrical spark in a car engine or lightning storms in the air. This also contributes to acid rain. Crude oil is a mixture of compounds, mainly hydrocarbons. A hydrocarbon is a compound which contains hydrogen and carbon only. Natural gas is also mainly hydrocarbons. Fractional distillation is the process used to separate crude oil into fractions. A fraction is a group of compounds with boiling points within a given range. Fractions can be separated by distillation because they have different boiling points, so evaporate at different times when crude oil is heated. They then cool down to be collected as liquids. The fractions from crude oil can be used for camping gas, petrol, diesel, candle wax and tar, bitumen, depending on their size and properties. Flammability is how easily a substance catches fire. Viscosity is how thick a liquid is. Volatility is how easily a substance evaporates. As the average size of the molecule in a fraction increases, volatility decreases, flammability decreases, viscosity increases. These changes are due to increased van der Waals forces between the molecules. The test for carbon dioxide is it turns lime water milky. The test for water is it turns cobalt chloride paper from blue to pink and boils at 100 degrees C and freezes at 0 degrees C. Hydrocarbons burn completely to produce only carbon dioxide and water. If carbon dioxide and water are produced when a substance burns, it means carbon and hydrogen were present. You can't be sure the oxygen came from the substance, as oxygen is in air. Carbon, soot, and carbon monoxide, a poisonous gas, are produced when hydrocarbons burn in a supply of oxygen which is insufficient for complete combustion. This is known as incomplete combustion. Removing sulfur compounds reduces air pollution. Lead compounds which are added to petrol cause pollution and cause brain damage. Air pollution from the burning of hydrocarbons can be reduced by special exhaust systems, catalytic converters, or by altering the fuel to air ratio. Transition metal catalysts, platinum and rhodium, can convert the pollutant gases to harmless gases. Reducing the fuel to air ratio improves the efficiency of combustion, thus decreasing pollution because combustion is more complete. Pollution from cars. Carbon dioxide, greenhouse effect. Sulfur dioxide and nitrogen dioxide, acid rain. Carbon monoxide and soot, incomplete combustion. Lead compounds from leaded petrol. Alternative fuels. Ethanol, from fermentation of sugarcane. Hydrogen, fuel cell, from electrolysis of water. Biogas, from decaying plant material giving 60% methane. Naming carbon compounds. Find the longest carbon chain with the functional group in it. Base name on this using same prefixes as alkanes. Number chain to give functional group lowest possible number. Name any side groups. Alkane-based groups become alkyl. Halogens such as chlorine becomes chloro. Give positions of side groups with number in front. Position of functional group in alkenes, alkynes, alkanols, given by number within the name, e.g. but-1-ene, butan-1-ol. Number not needed for position of functional group in alkanoic acids, always carbon number 1. Side groups listed in front in alphabetical order, ignoring any prefix such as di or tri. Ring compounds named to give its lowest numbers possible. Full structural formula shows all bonds, do not forget the hydrogens. Shortened structural formula only shows bonds to side groups, H atoms listed next to each carbon, e.g. CH3, CH2, CH3. Alkanes, generic formula, CnH2n plus 2. Reactions: substitution with bromine, needs UV light. Cracking, using aluminium oxide will give you an alkene. Alkenes, CnH2n, carbon to carbon double bond, formed by cracking of an alkane with aluminium oxide as a catalyst, dehydration of an alcohol with aluminium oxide again as a catalyst. Reactions: addition, H2 hydrogenation will give you an alkane, platinum catalyst. Bromine solution, dibromoalkane. This is the test for unsaturation. It is the test to see if there is a double bond present. Water, hydration, which will give you an alkanol. Alkynes, carbon to carbon triple bonds. Addition, reactions similar to alkanes but can undergo more. Cycloalkanes, CnH2n. Isomers with alkenes, but similar reactions to alkanes. Cannot undergo addition, so don't decolorize bromine solution. Cycloalkenes and cycloalkynes undergo addition reactions. Alkanols, CnH2n plus 1 OH, contain a hydroxyl group, the OH. Ethanol formed by fermentation, or it can be formed by hydration of an alkene using a catalyst. Reactions: dehydration, where you're using an aluminium oxide catalyst to give you an alkene. Combustion, where you'll be given carbon dioxide and water. Oxidation of a primary alcohol, that will give you an alkanoic acid, ethanoic acid. Esterification with an alkanoic acid will give you an ester. Alkanols have higher than expected melting and boiling points due to the polar OH bond. This creates strong hydrogen bonds between molecules on top of the van der Waals forces. Alkanoic acids, carboxylic acids, they have a general formula of CnH2n plus 1 COOH. They contain a carboxyl group, as in picture. They are weak acids, they're not completely ionized. They can be formed by hydrolysis of an ester. Reactions of alkanoic acids: neutralization with an alkali, metal oxide, metal carbonate, also react with mazonyl metals in a displacement reaction. Similar reactions to those seen with normal acids. Esterification with an alcohol, so you'll finish up with a chemical called an ester. Uses: food, vinegar, ethanoic acid, limescale remover, methanoic acid, making esters. Solvents. Esters contain an ester functional group. They are sweet smelling and tasting in perfumes, flavourings and solvents, paints, formed by condensation reaction between an alkanol and an alkanoic acid. Concentrated sulfuric acid is best catalyst, as it is a dehydrating agent as well as an acid. Reaction is reversible. Reverse reaction is called hydrolysis. Condensation is a combination of two molecules of water being kicked out during the reaction. Naming: alkanol becomes alkyl, alkanoic acid becomes alkanoate, giving an alkyl alkanoate,